Welcome back, ladies and boys. We are going to talk about finding the nth term in a sequence today. And I am excited about this one. I love finding the nth term. And you're probably going to ask, what the heck is the nth term? What do you mean the nth term, Barton? Just give me a number. We'll talk about it. So we got to clarify what this nth term thing is. And then we've got two formulas you've got to learn today. They're pretty straightforward. I'm going to hopefully show you where they come from. You're probably going to hate that part because it's a lot of convoluted, logic-y type math stuff. But once I tell you the formula, it's pretty straightforward to just beat the sequence to death with it and figure out what you want to know. So, without further ado, let's get right into it. So we want to start by talking about what the heck is an nth term, and then how do we find it for a sequence. So we're going to derive the formula for the nth term, and this one specifically is for the arithmetic sequence. In case that's not clear by the sequence here, in case you can't just look at this and tell, like big brains like myself. So let's talk about this nth term business. There are n. Let me start over. N is what's called the term number. Okay, the term number just tells you which number in the list you're on. So if you number all of these like in order, what's the first number, what's the second number, what's the third number, we call those n's, the term numbers. And then these are the values of those term numbers. So we'll think about it like this. Let's make a little chart here. So when n is 1, we're talking about the first number in the list, and then the value of that first term, a sub 1, would be 3. When we say n is 2, we're talking about what is the second number in this list, and the way we would talk about this number specifically, the value of the second term would be a2. And these little numbers here, these are called subscripts. And subscripts are just notes to yourself. They don't tell you to do a math operation. Those would be superscripts. So if you have like 3 to the power of 3, this means take 3 and multiply it to itself 3 times, correct? This is a superscript. Super meaning higher or like up, right? So super means up, top. So it's a number up top. This tells us to do a math operation. It tells us repeated multiplication. Subscripts, sub as in like submarine, sub sandwich, sub, I don't know, another word that starts with sub. Sub means lower, so number to the bottom. Subscripts do not tell us to do a math operation. They're the way mathematicians write notes to themselves because it can get a little confusing with all the numbers flying around. So sometimes it's helpful to have notes, right? So now that we've cleared that up, okay, n is just our term number. It's telling us which term in the list we're on. And then a with a subscript, the subscript is going to tell us which number we're on. It's n. And the a is just telling us the value of the number in that position, right? So if we keep going, it would look kind of like this. Right? So if I said, what is the fifth term, right? This one will always be n. They'll say, what is the fifth term? That means n equals 5. So you go look at the fifth term in the number, and we're looking for 19, right? So a5 would equal 19. And that's kind of what we're talking about. So what we are trying to do today is figure out, if I say, what is a 201? One way you could approach that problem is we can look at this sequence. We can figure out the pattern. It looks like they're adding 4 each time, right? We could just keep adding 4 until we have 201 numbers in this list, and then you get there eventually, right? But adding 4 201 times is not a healthy way to go about this problem. It's doable, but that's like trying to nail stuff together by punching a nail over and over, right? You're either going to have to punch it lightly enough to not injure yourself, and you're going to have to just do that like a trillion times, or you're going to hurt yourself and give yourself hand damage by punching the nail too hard. Either way, you're going to have a bad time. So instead of just doing 9, all right, the 9th term, add 4, this is 35. The 10th term, add 4, this is 39. And then doing this like 200 more times, we want to come up with a formula that is going to just, we plug some stuff in and then it spits out the answer for us. So we don't have to repeat this over and over and over, because that's going to make us want to go punch nails into boards or something, you know? So let's see if we can try and figure this out. Hint, we can, because I already know the answer. But we'll figure it out just for who's sake, right? So we want to know, what is the nth term? The way you talk about the nth term is you say a sub n. So this is the value of some random term n. N could be 5, it could be 10, it could be 201. We don't really care. We want a general formula. All right. Well, it starts at 3. Okay, so maybe that should show up here. Let's put a 3. And then what are we doing each time to go to the next number? Well, we're adding 4. Okay, so plus 4. Okay, well, an equals 3 plus 4, it's 7. So every single term equals 7. Not quite. We need to somehow tell this equation how many times to add 4. So think to yourself, what is the way in math we show repeated addition of the same number? Do we just put plus 4, plus 4, plus 4? No. This is how you did it in like your pre-kindergarten stuff, right? Then you went to kindergarten and they taught you a new math operation. What was it? Multiplication, Mr. Barton. Multiplication. You're right. We have to multiply the 4 by how many times we want to add it. Well, let's try n. Let's just be ignorant and be like, oh, well, if I want the 9th term, maybe n times, 9 times. We multiply by the term we're on. Let's see if this works out. Because we have the first 10 terms, let's try and find a 10 with this formula we just made up, right? We're guessing here. So we have 3 plus 4 times 10. Okay, 4 times 10 is 40 plus 3, that's 43. That's not quite it. Let's look. What's the 11th term? Plus 4, 43. So we went too far. If we want the 10th term, but we plug in 10, we get the 11th term. That's kind of weird. Let's see if that happens again. Let's try a smaller one. What about let's say 5, right? So it's easy to check. So it's 3 plus 4 times 5. 4 times 5 is 20 plus 3. A5 is 23. Let's see. 5, 23. No, we got the 6th term. We got the one after it again. So if I want the 5th term, I should plug in 4, right? Because we'll get the term after it. So whichever term we want, we need to plug in the number before it. So instead of plugging in n, we're going to plug in the number before n. So how do we decrease n by 1? Well, let's just subtract 1. There you go. So let's go look at the answer now. Here is the beautiful general formula for the nth term for, again, an arithmetic sequence. Okay. So let me kind of break this thing down for you so that you know what you're looking at. So an, this is the nth term. This is the value, let's write this down, value of the term in the nth spot. Okay, so this could be, if n equals 9, this would be the value of the 9th term. It would be this number right here. It's the value of whatever term you're on. Okay, a1, this is your starting term. This is the first term. Value of the first term. Okay, now let's go look at our formula. That's what this was right here, right? We started at 3, so we said, all right, it's going to be 3 plus something. What was the plus something? This something here, the 4, that's the number we are adding over and over. There's a special word for that. It's called our common difference. Ah, right there. This is our common difference. All right. And again, the common difference is just the number you're adding repeatedly. And then times n minus 1. This minus 1 is because when we plugged it in, we kept getting the number after the one we wanted. We were adding too many of them. So we had to take 1 off of that to plug in the number before it. One way you can kind of see why this happens is, let's think about the third term just to keep it easy. The third term is start at 3 plus 4 plus 4. So to get the third term, how many of these little plus 4s did we have to do? 1, 2 of them. Because the first term doesn't have the plus 4 on it. It's just whatever number you start at. You didn't add 4 to get that first term. So if you want to go to the third one, you're adding 2 times. If you want to go to the sixth one, 1, 2, 3, 4, 5, you're adding 1 less time than whatever term you want to end up on, right? What's nice about this is if we try and get the first term, we have to add 0 times, right? We're already on the first term. It should be 3 plus 0. So if you plug in 1, the minus 1 makes this times 0, and this thing cancels out. So this minus 1 is just because whatever term you want to end on, you're adding your common difference 1 less time than that. So this is your formula to find any term in the list without having to list them all out, right? This is just a way for you to add 4 enough times to get that last number, basically. So take the term you start with, add your common difference times 1 less time than whatever term you want to end on, and that will give you the value of that final term. So let's go test it out. Take it for a test drive on this arithmetic sequence. So we want to find the 103rd term in this sequence, and I intentionally made this a really big number so you wouldn't be tempted to just write out 103 of them and skip using the formula. The formula is there to make your life easier, not harder. So I'm going to force you to use it by making it too hard to do it the easy way, if you will. So let's see what we need. We're looking for an. So if that's a question mark, that's totally fine. We need to know, what is the first term? Where do we start? We need to know how much are we adding each time? And then we need to know what term number are we stopping on. So we need 3 pieces of information. We need a1, which is the first term. We need our common difference, which is d. And then we need to know n. How many, or which term do we want to end on? So a1 is 4. It's that first number right there. We'll skip the common difference for a second. That's a little harder to get. n, they tell you in the question, find the 103rd term. So n is 103. The taking away 1 is built into the formula, so we can just plug in 103 for n and it'll take care of itself. Okay. Now to find our common difference, in case you can't tell what you add to 4 to get to negative 18, remember the way we find d is take any number on our list. So I don't care, let's just pick a random. Let's do negative 62. So negative 62 minus the number before it, so negative 40. And then we simplify this. So minus a minus is the same thing as plus. So this is negative 62 plus 40. Type that thing into your calculator and it will tell you negative 22. So we are subtracting 22 each time. Now that we have these three numbers, we're going to just plug them into this general formula, and this thing will spit out the value of the 103rd term for us. So A, 103, because we're looking for the 103rd term, is equal to our starting term plus our common difference times n minus 1. So 103 minus 1 is 102. Then you grab your calculator, which I have totally 100% already done ahead of time, so I don't need to do it on the fly. You multiply these two numbers, and then you're going to add 4. And you'll get that the 103rd term is negative 2,240. So you could do that if you really, really felt like it. You could subtract 22 102 times, and then you get this number. But luckily, we have a formula that prevents you from needing to do that. All right. Let me just make sure. I thought I had another example, but I guess not. All right. So hopefully the arithmetic one is pretty straightforward, right? Like you take the formula, you find your three numbers, you shove them in the formula, you're good to go. Let's talk about deriving, or deriving is just the fancy way in math of saying figuring out on your own the formula for the geometric sequence. Okay, so we want to know what is Gn, and I'm going to use G here for geometric. I used A here for arithmetic. So if you see A's in the formula, it's arithmetic. If you see G's in the formula, then you're looking in a mirror. A, gotcha. But Gn, we're looking for the nth term or some random term way later in the sequence of a geometric sequence. So it's probably going to depend on where you start. So it equals where you start. And then let's think about what we're doing here. In a geometric sequence, you're multiplying. So this is times 4, times 4, times 4. So you're multiplying by 4. So we should probably multiply by 4. And then we're doing that a repeated number of ways. How do you show repeated multiplication? Well, if you think back to your kindergarten class, you think of exponents. So we're going to do an exponent. Let's just try n. Remember, last time n didn't quite work, but we'll try it and we'll see just to make sure. And we can adjust it. We're pretty smart. We'll figure it out. So here are our GNs. Here's our n's. So the first term is 3, second term is 12, third term is 48, fourth term is 192, and then the fifth term is 768. So let's just plug in a nice low one. Let's try and get the third term, shall we? So G3 will be 3 times 4 to the n, which would be 3, third power. So what is 4 to the third power, you ask? It's 64. And then 64 times 3, hold on. 64 times 3 is 192. Oh no, that same thing happened. We were aiming for the third term, but we got the fourth term. So if I want the third term, it looks like I have to plug in the n before it. So we're going to have to put that -1 again. The reason for this, again, is because you start with your first number, and then to get to the third term, you only multiply by 4 2 times. So whichever term you want to end on, you have to do one less multiplication than that. So if you want the fifth term, you multiply 4 times, right? 1, 2, 3, 4. So that's where this -1 comes from. It's just making sure we don't accidentally multiply too much. So that brings us to our general formula that will work on any geometric sequence. So Gn, this is just the value of the nth term. So it's the value of the term you're looking for. And n could be any number you want as long as it's a positive integer. G1, the 1 indicates n equals 1. This is your first term. R is your common ratio. Just because it's a geometric sequence, it has a different name. But this is the number that you are multiplying by every time, the common ratio. And then n is your term number, which just means if you're looking for the fifth term, n is 5. And then the -1 so that you don't accidentally multiply 1 too many times. Okay, let's go take this bad boy for a test drive. I have 2 examples, one that's super easy peasy, and then one just to make sure you're staying on your toes, and we'll get you out of here. So, oh, actually, maybe, no, I lied. Just wanted to keep you on your toes. We'll skip the baby one, and we'll go straight to the on your toes one. So we need to find 3 numbers again. We need to know what is the first term. We need to know what is our common ratio. And we need to know what term number are we looking for. So let's go find those. G1 is always really straightforward to find. It's 4. Our common ratio, we need to do a little bit of math to find. So just like for the arithmetic sequence, we took a number and subtracted the one before it. We're going to take a number and then divide by the one before it. So -108 divided by 36 is -3. You can see how it goes positive, negative, positive, negative, positive. That means you are multiplying by a negative each time to switch the sign. So r is -3. The negative is important here. Don't get rid of it. You're not wrong. It's there for a reason, I promise. And then the last thing we need to know is n. What is the nth term we're looking for? And in this case, it says 23. All right. I'm going to warn you ahead of time. This number is going to be pretty big because this is going to be an exponent. Anytime you have exponents above like 6, your number is going to be pretty big, like at least a couple thousand. Because this is 20 something, we're probably going to be in like the hundreds of thousands or maybe even millions. Who knows? Maybe billions. That would be exciting. So let's go find it out. So G23, because we're looking for the 23rd term, equals G1 times your common ratio. And it's really important here that we have the negative inside a set of parentheses when we do the exponent. If you have -3 to the 23rd power, this will actually tell you the correct answer. But if this were an even number, hold on, like to the 24th power, then if it's an even exponent, it's going to mess up, and it'll tell you a -1 even though it should be positive. That's because it does the order of operation goofy. So just make sure that you put that bad boy in parentheses. So to the n minus 1. So 23 minus 1 would be 22. All right. Now we put this thing in our calculator. Don't forget the parentheses around the negative thing. Otherwise, your exponent will mess up. And we get, holy smokes, I was right. This is a big number. G23 equals let's see. Let me write it down, and then I'll put the commas in, and then we'll figure out how to say this thing. 8, 4, 3, 6. Okay, comma, comma, comma. All right, so let's see. Hundreds, thousands, millions, billions. So this is 125,524,238,436. Whew. Okay, there you go. So that's math, baby. All right. And now you know how to find the nth term. All that's left for you to do is go practice driving your new equations. So don't forget to subscribe. Make sure you hit the bell icon for notifications. If you wouldn't mind, give me a little like. Maybe share this with a friend even. Ooh, tantalizing. And until your next video, have a wonderful time, ladies and gentlemen.